Smart dusts are sensors in nanotechnology. They are designed to monitor everything almost like electronic nerve endings for the planet. The idea of smart dust emerged in the 1990s by a researcher named Chris Pister from the University of California, Berkeley, mainly as a potential use for military applications. The project officially came into process in 1998. In 2010, Hewlett-Packard, or HP, announced that they are working on a project they refer to as the central nervous system for the Earth. Within the coming years, HP plans to have over 1 trillion sensors everywhere. Although it was mainly meant for the military, it can also be applied to almost any other industry. Smart dust can be very useful in terms of predicting and monitoring events such as traffic patterns, energy use, and earthquakes. Currently, the sensors that are being developed are larger than what one would expect the size of an actual fleck of dust. Berkeley researchers, however, are presently in the works of making one a cubic millimeter, hoping that they will be manufactured to a smaller size as the project develops over time. Smart dust's goal is to create something so minuscule that includes elements that are necessary in order to execute the sensory measurements it is designed to do so while communicating back to a base station or the command computer that gathers all the data. Smart dusts are small wireless microelectromechanical sensors that are able to sense anything from light to vibrations. The microelectromechanical sensor is the combination of sensors, electronics, actuators, and other mechanical elements on a common silicone substrate. The microelectronic integrated circuits in the smart dust acts as the brain of the system. Inside the smart dust, there are nodules that are called modes, which includes sensors, digital circuitry, bidirectional wireless communication technology, and also its power supply that is incorporated on a minuscule dust-sized device. The modes are battery-operated devices where the sensors work directly with the mode processor. Digital circuitry is what permits the modes to become small while still having the capability to have a battery, a minimal amount of random access memory, and also a wireless transmitter. The sensors that are integrated inside the smart dust transmit signals back to a command computer through wireless connection. The wireless transmitter is most likely powered by radio frequency identification. Wireless communication systems are required for data in terms of sending and receiving with a transfer rate of 1 kilobits per second. The wireless communication that is used must be bidirectional between the dominant transceiver and up to 1,000 dust modes. Altogether, these individual technologies combined enable smart dust to perform its necessary actions.
After pioneering and heading the Smart Dust project at the University of California, Berkeley, Chris Pister went on to found Dust Networks. Dust Networks has since become an acquisition of Linear Technologies and produces a trademarked SmartMesh. SmartMesh offers embedded wireless sensor networks that boast unmatched data reliability over ultra-low power, secure wireless communications, enabling sensors to be placed anywhere in tough industrial Internet of Things environments. Dust Networks is defining the way to connect to smart devices with current applications in data center, industrial automation, renewable energy, building automation, remote monitoring, and transportation. Smart dust is still very much in a developmental stage. Research teams, like that of the MEMS laboratory at Carnegie Mellon University, are working toward overcoming technical obstacles that prevent the mainstream adoption of smart dust. Other than creating smaller motes, fusing MEMS and electronics onto a single chip has proven difficult. Illustrating the complexity of this issue is the collaboration of departments Carnegie Mellon must utilize to run their MEMS laboratory, including the Department of Electrical and Computer Engineering, the Robotics Institute, part of the School of Computer Science, and the Institute for Complex Engineered Systems. In the broader scope of microelectromechanical systems technology, the 5 major players are producing in a variety of fields. The leader of 2014 MEMS sales, according to Yole Development Research reports, was engineering company Robert Bosch, driven by MEMS for smartphone sales, including pressure sensors. In 2014, the sales gap between Bosch and the second largest seller of MEMS devices, ST Microelectronics, was over $400 million. This multinational electronics and semiconductor manufacturer holds a unique sensor portfolio including UV index, temperature, touch, and pressure sensors, accelerometers, gyroscopes, and digital compasses. Following ST Microelectronics is a brand many students are familiar with, Texas Instruments. While those taking math courses may know them for their scientific calculators, their registered, trademarked digital light processing chipsets are the world's leading projection display technology, including digital cinema, business, education, and home theater applications. Hewlett-Packard's MEMS are drawing attention from the tech community as they may soon shake up motion sensing. HP's MEMS sensors are optimized for seismic imaging applications being used for oil and gas exploration. Rounding out the top 5 in 2014 was Knowles Electronics, with a unique focus on microphones. Their trademarked Sysonic series was the world's first surface mount microphone and is still preferred by most cell phone companies today. The MEMS technology platform is used in microphones for mobile handsets, smartphones, and tablets within the consumer electronics market.
According to ComputerWorld.com, the SmartDOS is currently the size of a grain of sand, 5 millimeters, but they want to get it down to 1 millimeter in size. SmartDOS is made up of sensors, computing circuits, bidirectional wireless communication technology, and power supplies. As shown by ComputerWorld.com, the price for the modes currently ranges from $50 to $100, but it is expected to drop down to $1 within the next 5 years. Potential commercial applications are varied, ranging from catching manufacturing defects by sensing out of range vibrations in industrial equipment to tracking patient movements in a hospital room. Most people believe that the biggest funders of SmartDOS will be the military, because with SmartDOS you could drop thousands of tiny sensors over a landscape and create an ad hoc wireless sensor network where there isn't one already. Also, you can do it in a way that's almost completely undetectable. It can also be applied to almost any other industry. SmartDOS can be most useful in almost every industry by predicting and monitoring. Some of the uses can be to track traffic patterns in roadways. By doing this, people will get a real-time update. SmartDOS can also be used to track inventory in warehouses. The modes can track down shortages in stock and order more, or let you know if there is too much of a product. They can also be used to control air conditioning and units in buildings, turning air on and off.
The advantages of SmartDOS. SmartDOS has many potential advantages that can revolutionize a vast array of industries. For example, when applied in traffic control, a system of SmartDOS modes or a large group of SmartDOS sensors could be used to monitor traffic, high areas of congestion, and wrecks down to the exact location. When applied to inventory control, SmartDOS can help businesses monitor their inventory by detecting when a certain item is out of stock and reorder it. In military uses, SmartDOS can be used as an improved perimeter system to help detect hostile or abnormal activity. An environmental advantage would be that SmartDOS could help scientists learn more about the environment and is able to detect changes in heat and temperature and thus be applied to help detect natural disasters. In business uses, SmartDOS could help businesses become more efficient by helping them cut energy costs and reduce man labor hours. The disadvantages of SmartDOS. Just like any other technological advancement, SmartDOS has its disadvantages as well. It ranges from security issues to environmental issues. An environmental disadvantage. SmartDOS can be damaging to the environment due to the fact that it is non-biodegradable, and once it is released into the environment, it cannot be retrieved. This would cause pollution and would damage the environment. A privacy disadvantage. The public would fear for their privacy due to the fact that SmartDOS could be easily deployed and could gather information about anyone without being detected. A security disadvantage. There would be a vast number of security concerns among many organizations where SmartDOS would allow anyone anywhere to obtain information no matter how confidential. This would cause problems in the military and in the public. An unemployment disadvantage. There would be a huge loss of man labor hours across various companies because SmartDust could replace a vast number of employees, thus making the employees unnecessary.
Engineers are hoping to reduce the size of SmartDust to millimeters small and less expensive to make. Once developed, SmartDust will be distributed throughout big cities to help manage the city's infrastructure purposes. Also, people will be able to access, send, and share the data that are collected from SmartDust just by using their mobile devices. Some examples of how SmartDust can help the cities are: if they are on a road, it can alert drivers to avoid potholes or anything that can cause damage to the car. During traffic hours, it will send mobile user alert about the density of the traffic flow and suggestions for alternative routes. This will minimize the traffic flow, help commuters optimizing their drive times, and decrease the chance of accidents. For bridges, it can detect the pressure factors so that individuals and community will be more alarmed in case something might happen. For buildings, it can recognize human beings and their activities and then respond accordingly by linking new data with its database. For example, it can boost start personal computers when entering the building if they are attached somewhere around the entrance. For streets, it can recognize human beings, the places they're at or going to, and the activities they're performing. For streetlights, it can detect the presence of pedestrian to intensify the level of light according to the pedestrian flow.